AP Calculus AB, Unit 7, Day 5, office hours, some free response questions. Now, there were some parts of these questions that you guys aren't really equipped to answer yet. It's hard for me to give you guys free response questions early in the year just because they usually kind of involve stuff from throughout the year. But these would be the parts of the problems that I specifically did want you to try out. I'll probably go ahead and demonstrate the other parts possibly on some of these just to show you, and you can follow along, and it'll be something that we will be doing later. But these free response questions are 9 points each. So one of the things to start thinking about is where you get your points. So this is 2, 2, 2, and 3 points out of the 9 points that you would get for this. And you'll do 6 of them on the AP test for a total of 54 points, which will be half your score, half your raw score. So this one you should be able to do parts A, B, and C. So A says find the derivative. So I would rewrite the function like this and take the derivative. Should be leave the inside the same. Chainable, multiply by the derivative of what's inside. I like to put parentheses around a lot of times, especially if it has negative or multiple terms. So that looks good, and then we can rewrite it nicely. The 2's cancel. It's going to be negative x over the square root of 25 minus x squared. And that's your answer. So there's 2 points, and they're both for just getting the derivative correct. So if you mess it up, you didn't get any points. You got them all or nothing. Okay. B says write an equation for the tangent line at x equals -3. So I feel like we've done that a lot this year. So far, I don't think this is requiring anything outside of even, anything from even within this unit. It's all before this. So tangent line, you need a point. So we could plug -3 into the original function. And get the y value. So our point is -3, 4. We need the slope. We already found the derivative, so we just plug it into that carefully. So that's your slope. So then you can do y minus 4 equals 3/4 times x plus 3, and leave it in point slope form. Just be done. Do point slope form, please. Some of you guys try and do slope and stuff. Skip point slope. That usually doesn't work out great. So that was 2 points. 1 point for getting the derivative correct, and 1 point for your final answer. Okay. All right. Show your work, label your answers, points along the way. C, let g be the function defined by, so here's a new function, piecewise function, that uses that function, f of x, -5 to -3. And then this other function, a line from -3 to 5. Okay. So, is g continuous at x equals 3? Use the definition of continuity to explain your answer. Now, we've been doing this kind of the lazy way before, right? The lazy way is if it's continuous, we usually just plug -3 in. And so we get f of -3, which I think we already calculated was 4. And then you plug in -3 into the other part and you get 4. And if they're equal, you're like, yeah, it's continuous. Okay. And that's fine for multiple choice. That's fine for my test so far, but that's not fine for free response. So let me show you. This is the technical way. What we have to do is we have to use limits and show that both sides approach the same value. And then that the value they approach is actually equal to the value of the function. That's the definition of continuity. So we have to say, okay, let's take a limit as x approaches -3 from the left of g of x, which will be more specifically, this is the work you have to show. X approaches -3 from the left of, now from the left of -3, that's this one, that's f of x, which equals the limit as x approaches -3 from the left of, well, f of x is the square root of 25 minus x squared. And if we do that, we get 4. So that's that one side limit. So now we need to do the other one side limit from the right side, approaching 3 from the right side of g of x. So as x approaches -3 from the right side, you have to use the superscripts. G of x on that side is x plus 7. And so that's going to give you 4. Which means that since they agree, therefore, the overall limit as x approaches 3 from both sides, -3 of both sides of g of x is 4. We're not done yet. That just proves that the limit exists, and that's the value. And since g of -3 equals 4, then that means the limit as x approaches -3 of g of x equals the value of the function at -3. So you got to prove the limit exists, one side, get the two side limit, and then you got to show that the actual value of the function, if you were to plug -3 into the appropriate, you're supposed to plug it in here, equals the limit. Therefore, g is continuous at, can't even spell, continuous at x equals -3 by the definition of continuity. That's 2 points. So it's not gonna, you're not gonna be able to do the lazy way on free response. Okay, now the 2 points here was 1 considers the one side limits. If you didn't show the one side limits, you lost it. And then 1 answer with explanation. So the fact that you even did one-sided limits, that's a point. Like, hey, good job. You knew that you should do that. And then the final answer with the explanation is 1 point. Now D, you guys can't do, but let's do it together. It says find the value of 0 to 5x square root of 25 minus x squared dx. So this is integration. So this is called an integral, and essentially it undoes derivatives. So we're trying to go backwards. So here's this thing. It has an inner function, outer function. So this is sort of like you're looking at an answer of a derivative. And it sort of like looks like a chain rule issue. And so we're going to do reverse chain rule by looking at the inside as the inner function. And this is called U substitution. It just helps. And so this is all going to go over your head, I'm sure. So here's this x dx, and I want x dx, and I want the -2. So I'm going to rewrite this -2, -1/2, integrate the square root of u du. So most of this stuff is going to go over your head, but maybe this step might make sense. So we're trying to undo this derivative. We just did a bunch of stuff to make it simple. That's power rule. So power rule usually multiply the derivative and then decrease by 1, but we got to do everything backwards. So we have to increase it by 1 and then divide by the new derivative. So usually multiply, decrease, now you increase and divide. And you got to put this plus, well, I'm not going to put the plus c because we're going to do something else. Now, divided by 3/2 is the same as multiplying by 2/3, right? So it's -1/3. I'm going to put it back in the terms of the original variables, 25 minus x squared. This u stuff was just temporary to kind of make it simpler. And then what we have to do is plug the limits in. You got to plug the top one in first. So it's going to be 25 minus 25 to 3/2. And then you can subtract the next one, plug the bottom limit in, 25 minus 9 to 3/2. Now that's 0, right? And minus minus is plus. And this is going to be 16. So we're going to have 1/3, 16 to the 3/2. I would do the 1/2 first and then the 3. So square root of 16 is 4, cubed is 64. This is going to be 64 thirds, but I've made a mistake somewhere. Oh. Plug 0 in. When you plug 0 in, I put 9 here. That's 0, so this should be 25. So square root of 25 is 5. Cubed is 125. So that's something we're going to be doing soon. But one answer was for the antiderivative. 2 points. That's pretty much for undoing the derivative. You get 2 points, and you get 1 point for your final answer. Okay, let's try the next one. So these problems should be able to be done in 15 minutes on average. Some of them may be quicker than 15 minutes because some problems might want more than 15 minutes. In the AP test, you have to do 6 of these back to back to back to back in an hour and a half. You have an hour and a half, 90 minutes to do 6 of them. That's 15 minutes each. They're each worth 9, but some are probably overall quicker than others. Consider a differentiable function. That might be something we need to know. Having domain all positive real numbers. So the domain is all positive real numbers. So x is greater than 0. And for which it is known that the derivative is, they gave us the derivative for x is greater than 0. So they're giving us the derivative, but they're not giving us the original function. Find the x coordinate. Okay, so the point breakdown here out of 9 is going to be 3, 3, 3 on this one. And so it says, find the x-coordinate of the critical point of f. Determine whether the point is a relative max, relative min, or neither for the function f. Justify your answer. Now, to justify relative max's mins, you got to probably use first derivative test, and you have to explain it. But first things first, we have the derivative, and we want to find critical points. So we got to set it equals 0 undefined. You need to write that down. If you don't write this down, you can lose points. I'm going to rewrite it like this. So undefined is when the bottom equals 0. So that's a critical point. And 0 is for the top, so x equals 4 is a critical point. Now, here's the deal. We're only supposed to be considering x greater than 0, so we're going to throw this one out and not consider it. Next thing I would do is I do a line check to help me find relative max's mins because I don't have a picture of the graph. Now, I'm going to put 0 on there still because it will affect your answer. So put it on there. Just be careful. I'm going to test a point, I don't know, far right, 5. It's going to be negative, positive, negative, decreasing, increasing, decreasing. But remember, we're not going to include that because the domain is 0. Is greater than 0. So this is increasing, decreasing. This is a relative max. Now you know the answer. You know where it's at. And they just want to know the x-coordinate. But you have to justify it. So to justify this, you have to say, let's see, f of x has a, well, first of all, they want a critical point. It has a critical point at x equals 4 since f prime of 4 equals 0. Okay. F of x has a relative maximum. I'd write this all out. Relative maximum at x equals 4 by the first derivative test for relative extrema. Okay, cool. Well, how does that work? Since f prime of x was positive on the interval 0 to 4, don't just say less than 4 because it's not true. 0 to 4 is positive, and f prime of x was negative on the interval 4 to positive infinity. That's it. Okay, now you got 1 point for identifying the critical point. You got 1 point for deciding what the answer was, and you got 1 point for the justification. Okay, B says, find all intervals on the graph of f, graph which the graph of f is concave down, justify your answer. Well, concave down, second derivative is negative, so that's, I think, what we have to do and explain. So where is f concave down? Well, we got to find the second derivative. We already found the first derivative. We could do quotient rule, or we could do product rule, either way. But I mean, it's pretty nice for product rule, I guess. 4 minus x times derivative is going to be negative 3x to negative 4 plus x to negative 3. So the derivative of that is going to be negative 1. I'm going to set it equal to 0 undefined to find potential inflection points. Now, I'm going to rewrite this. Let's see. This is going to be negative 12 plus 3x over x to the fourth. The negative 3 doesn't end up in the denominator. Minus 1 over x cubed. Now, what we want to do, we don't want to cross multiply it. That will mess you up. So I'm going to give these guys at least common denominator and combine them in the same fraction. So that's going to be negative 12 plus 2x over x to the fourth equals 0 undefined. Now, undefined comes from the bottom, x equals 0. And 0 comes from the top, that's going to be x equals 6. So then we're going to do a line check. I'm put 0 on there, and that's a bounce issue. And then I got 6. I'm going to test the value, x equals 7. It's going to be positive, negative, negative. Concave down, concave down, concave up. We're not considering this because we're only supposed to consider positives. But I would put that on there, and you could test a negative number and pull this off correctly. That's why you should keep that critical point in your work and stuff. You can test a negative number and pull it off correctly, and some people might accidentally, and if they ignore that 0 critical point, it would mess up their answer. So we just need to answer the question now. We say the graph of f is concave down on 0 to 6 since f double prime of x is negative on 0 to 6. That'd be your justification. Okay, C says, now the points there, by the way, you got 2 points for just getting the second derivative correct. And then you got 1 point for the answer with justification. Okay, 3 points. Part C, given that f of 1 is 2, determine the function f of x. Now, this is something that you really can't do yet, shouldn't be able to do, but let's talk about how to do it. You're trying to find the original function. Now, what we have from the beginning is we have the derivative, right? The derivative was 4 minus x times x to negative 3. And what we want to do to get back to the original function is to undo the derivative, which is, that's integration. And to do this better, I think we should distribute this. So that would be 4x to the negative 3 minus x to the negative 2. And so we're trying to undo these derivatives. I think you guys could probably kind of grasp the concept of this. So there's a 4 that's just going to be there, just like with derivatives. If there's a number of 4, it's just going to be there. Now, the power, we have to bump it up 1 and divide by the new exponent. So we got to do everything backwards. Usually we multiply by the exponent and then decrease the exponent. Now we're going to increase the exponent and divide by it. Bump it up, divide by the new exponent. Okay. And then usually what we do is we do a plus c because there's some extra constant. So this is negative 2 over x squared plus 1 over x plus c. So this is the function in general, but we want to find it specifically what it is. And that's where this, we call this initial condition comes in. If I plug 1 in, I should get 2 out. And so that's going to help us figure out what C should be. So this is negative 2 plus 1. That's negative 1 plus C equals 2. So C equals 3. So your original function is now f of x equals negative 2 over x squared plus 1 over x plus 3. That's the original function. Now on this problem right here, you get 1 point for just setting up the integral. You get 1 point for getting the antiderivative correct. And you get 1 point for getting that C value, getting your final answer right. So that's something we're going to be doing more of very soon. We're going to be undoing derivatives. Okay, next problem. Now this problem, I wanted you to try and do parts C and D, but I'm going to do the whole thing with you just to kind of show you guys some of the stuff that's coming up. And I did add something. I added this right here because maybe that probably wouldn't be obvious to you. It says let f be a continuous function defined on negative 4 to 3, whose graph consisting of 3 line segments in a semicircle centered at the origin of given above. So this is the graph of f. But then they say let g be the function, where g is the integral of f. And so there's this, and it says find the values of g2 and g negative 2. Well, g2 will just be, we plug a 2 in up here. And integrals, one way to interpret them is that they're the area under a curve between the curve and the x-axis of the graph. And so from 1 to 2, it's just this little chunk right here. We're just trying to find that area. And if it's below the x-axis, it comes out negative. So we could really just do like area of a triangle. It's going to be negative 1/2. The base is 1. The height is, well, if we go over 1 and it goes down, if we go over 2 and it goes down, this is going to be 1/2, right? Negative 1/2. And so that's going to give you 1/4, negative 1/4. That's g of 2. Okay. So integrals are also the area under graph. G of negative 2 is going to be 1 and negative 2, f of t dt. Now, negative 2 to positive 1 is going to be all of this. So it's going to be this, and it's going to be all of this. But because we're going backwards, negative to a positive, or yeah, the bottom one's where you start, the top one's where you end. So since we're going left to right, backwards, whatever answer we would get going left to right, we got to make it negative. So it's going to be negative of, now this is going to be positive 1/2 base times height. This one would be negative on its own. It's going to be 1/2 of pi r squared. The radius is 1. And so we're going to get negative 3/2, right? We got to distribute this in, plus pi over 2. So that's g of negative 2. So that's part A. Now the point breakdown here is 2, 2, 3, 2. And so you got a point, 1 point for that answer and 1 point for that answer. There's no half points. Part B says, for each g prime negative 3 and g double prime negative 3, find the value or state that it does not exist. So we're trying to find g prime of negative 3 and g double prime of negative 3. Now, g prime is the derivative of g. And so what we're going to do is we're going to have to take the derivative of this function right here. Now, I just told you right here g prime equals fx, but I'm going to show you right now how that works. I'm going to take the derivative of an integral. Now, since integrals undo derivatives, right? Since integrals are derivatives backwards, if we take the derivative integral, they kind of cancel each other out. But then you got to plug the limits in, and you got to take the derivative limits. It's a chain rule idea. Minus, you plug the bottom one next, but you can multiply by the derivative of that. And so what happens is, from this, we're able to say that g prime of x equals f of x. Okay? G prime of x equals f of x. Now, we're going to need to use that part C and D that you're going to do, but that's why I just gave it to you. So in this problem right here, g prime of 3, negative 3, equals f of negative 3. All you have to do is look at the graph and say, what's the value at negative 3? It's 2. Right? And then g double prime of negative 3 would mean it's going to be the derivative of the graph at negative 3, which means the slope of that line right there. It's up 2 over 2. It's a positive 1 slope. Because now what's happening is this is actually the graph of the derivative. We've done a lot of work with graphs of derivative, right? In fact, it's going to be on this upcoming test where I give you the graph of the derivative and ask you to answer questions. C says, now this is where I wanted you guys to start doing it, using this fact that I just gave you that we had to kind of figure out on our own if originally. C says, find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative min, relative max, or neither a minimum nor maximum at these points. Justify your answers. So they're saying, find the x-coordinate where it has a horizontal tangent. That'd be a flat, well, the graph of G. Since this is the graph of G prime, let's write this down. G horizontal tangent means we want to know when is G prime of x equals 0, but G prime equals f of x. So we want to know where's f of x equals 0. This is a critical point for G. This is a critical point for G. That's where G has a horizontal tangent. So let's see. We got to justify our answers. So G has a horizontal tangent line at x equals -1 and +1, since G prime of x, which equals f of x, equals 0 at x equals -1 and 1. So that's a good, thorough answer with justification. Okay? For your response, you can't just be like, oh, I did it in my head. Now, right here, they said if you just consider G prime of x equals 0, you get a point. You got to make sure to write that stuff down. If you don't, you're losing a point. That is critical information to what you're doing. That is the calculus. Okay, the fact that you got x equals -1 and 1, that was a point. Now I got to decide at -1 and 1 if either of them are relative mins, maxes, or neither, and explain why. Now, looking at the graph, I know that G prime is positive here. So it's increasing. And here G prime is negative, so it's decreasing. And here G prime is negative, so it's decreasing. So I can quickly say, it's going up and down. This is a relative max for G, right? And then it's going down and then down. This is not a relative max or min. It's a plateau for G. Now I got to put that in words and justify it. That's the hard part. So we're going to say, let's see, G has a relative maximum G has a relative maximum at x equals -1. Okay, why? By the first derivative test for relative extrema. Cool. I'll explain how that works. Okay. Since G prime of x, which you don't have direct information of, so you need to keep tying it back to f of x, since G prime of x, which equals f of x, is positive on the interval -4 to -1, right? And G prime of x, which equals f of x, is negative on the interval -1 to 1. So that's your justification right there. That's first derivative test. That's putting in words. It's about the derivatives going from positive and negative, but you have to tie it to the information they gave you. You have to tie it to that. Okay, so that's one answer. Then we also need is we can't just ignore g of x has neither a relative minimum or maximum at x equals 1. Why? Since g prime of x, which equals f of x, is negative on the interval negative 1 to 1 and stays g prime of x equals f of x negative less than 0 on the interval directly after it, 1 to 3. Now, the points for this is 3 points total. You already got 2 of the points. All the rest of this work here was 1 more point. It's a lot of work for 1 point. But it does go to show you should start the problems. Even if you're like, I don't know if I can finish it. Start it. Get points. D says for negative 4 to 3, find all the values of x for which the graph of g has a point inflection. Explain your answer. Explain your reasoning. So we're only looking at negative 4 to 3, which I think is what the graph shows anyways. And we're trying to find inflection points, right? So we got to take the second derivative. Now, I think they're, so the second derivative is the derivative of the first derivative. So this is g double prime is positive, it's concave up. G double prime is negative, concave down. G double prime is negative, concave down. Now I split it up because at negative 1, G double prime is not concave down because it's not defined there, derivative, because there's a little bit of a corner there. Here, G double prime is positive, concave up, and here, G double prime is negative, concave down. So the inflection points are where it changes concavity from up to down, from down to up, and from up to down. So there's 3 inflection points. Now this is the way I usually do it, but on free response, we can't just say, hey, look at all the stuff I drew on the graph. They're not going to look at anything you drew on the graph as credit. That's just to help you figure out how to say it. So I'm going to say G has an inflection point at x equals negative 2 since g double prime of x, which equals f prime of x, is positive on the interval negative 4 to negative 2. And I could probably say concave up, and then g double prime of x equals f prime of x is negative, concave down, on the interval negative 2 to negative 1. So we got to do that for each of these. G has an inflection point at x equals 0, since g double prime of x, which equals f prime of x. You got to keep tying it back to f, because that's the information you are looking at that they gave you, is negative on the interval, negative concave down on the interval negative 1 to 0. I wouldn't say negative 2 to 0 because it's not concave down at negative 1. Negative 1 to 0. And then g double prime of x equals f prime of x is positive, concave up on the interval 0 to 1. Okay, then we got one more. G has an inflection point at x equals 1 since G double prime of x equals f prime of x is positive, concave, up on the interval 0 to 1, and then G double prime of x equals f prime of x is negative, concave down on 1 to 3. I mean, that's it. That's the full explanation. That's it. That's technical. All right. Last one. This one, I want you to try and do parts A and C. I'll probably do the other parts right now just to show you how to do it. I'm on pace. I've done 3 problems in 36 minutes, so I'm doing average 12 minutes problem. Okay, this is one that you can use a graphing calculator on. So I'm going to get my graphing calculator. I'm not sure if it's for the parts we're doing, maybe. Okay, I want you guys to do A and C. But let's look at this. So this is a 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by RT, measuring liters per hour, where R is given by the piecewise function. So water is being drained out. So we're losing this. And this is a rate. This is a derivative. Okay. And at time 0, the tank was full. So we probably need that. So A says, is R continuous t equals 5? Show the work that leads to your answer. So this is actually just like part C on the first problem. Trying to prove that something's continuous. Try and prove a piecewise function is continuous. So now see if you can do it. I did that first one for you. Maybe you got stuck. Now you got to see, can you redo that kind of same work for this one? Try it. Just watching me and writing down what I write down is not going to get you very good at it. So it's 5 that's the issue here. So we're approaching 5 from the left-hand side of RT. You got to write all this out. Got to get technical here. So that means we're doing the left would be 600t over t plus 3. Now we're not plugging negative 5, we're plugging positive 5 in. And so if you plug 5 in here, you get 3,000 over 8, which is 1,500 over 4, which is 750 over 2, which is 375. Okay? So that's the limit as you approach 5 from the left-hand side of RT. Okay? So then we got to take the limit as we approach T from the right-hand side of RT. And so that's going to be the limit as T approaches 5 from the right-hand side of this other one, 1,000 over e to the negative 0.2 t. I'm going to rewrite as positive exponent. Now, technically, you're not supposed to plug 5 in here, but I'm going to plug 5 in because this function itself is continuous, and substitution should work unless I get like a indeterminate form or something like that. So this is going to be 1,000 over e to the first power, right? Which is 1,000 over e. Which looks bad because the one-side limits have to agree for the overall limit to agree to even look at it. So we got to write something about that. Since the left hand, one on the left side, left hand and right hand limits are not equal, then RT is not continuous at t equals 5. So it's continuous other places, but at t equals 5, it's not. So, and that's the definition of continuity. Okay, B says find the average rate at which the water is draining from the tank between t equals 0 and t equals 8. Average rate sounds like average derivative, right? So, but also 0 to 8 also requires that the original function be continuous, which it is not, and differentiable, which it is not. So we can't use the mean value theorem for derivatives. We can't do it because the requirements are met. So that's not going to work. There's another way. Now, by the way, R is already a derivative itself. So R prime is the derivative of the derivative. This is the way we're going to do it. And this is the other mean value theorem that we're going to bring up soon. If you want to find the average of a function, so there's another mean value theorem for functions in general. And this can be applied to derivatives too, because derivatives are functions. And it says the average value of a function is the integral of the function, which is the area under its graph, from one point to another point, and then you divide by the difference in those. I'm going to explain that in more detail sometime soon in another lesson. You guys don't need to know how to do this now, but this is how you do it. Now, since this function is a piecewise function, we can use this idea, but we're going to have to break it up and integrate this part and this part separately, which is going to really find the area under the graph. So I could say, well, it's 1 over, I'm trying to go from 0 to 8, so 8 to 0. And we could write it like this. The issue is that we have to calculate each of those chunks separately. We have to do 0 to 5 of 600t over t plus 3. And then we got to do 5 to 8 of the other one, 1000 over e to the 0.2 t dt. Now, it is potentially possible that we can maybe do these by hand. You guys don't even know how to do them by hand, but this is where the calculator comes in, because we actually would get stuck on this trying to do it by hand, even if we knew how to do these. And so I'm going to do this all on my calculator. I would probably, at the very beginning, enter these functions into my Y menu with the anticipation that I'm going to use them possibly more than once, and I don't want to have to retype them in. So I would type them in. Now, let's see. I'm going to put parentheses around the denominator just to make sure. E to the 0.2, and I'm putting x's for the t's. So that's that. I need to make sure I'm in Radian mode, which I am. I'm going to do this from the home screen. I'm going to say 1 divided by 8. I'm going to do this all in one line. Parentheses, math 9, vars, y vars, function. y1 was the first one, right? Comma x, comma 0, comma 5, minus math 9, vars, y vars, function y2, comma x, comma 5, comma 8. It pays to know how to use your calculator fast. This is by far the fastest way to do it. This is going to do it all at once. That gives you 50.574099109. But I feel like I made a mistake. Oh, I got it wrong answer. Let's double check this. That looks good. That looks good. My calculation. Oh shoot! I'm supposed to add these. That's it. Okay, 258.0527451. Okay, so the answer is the average value is 258.052 or 3 if you want to round, which I don't recommend. What are the units of this? Well, this is R is already liters per hour, so this is going to be liters. This is the derivative of that. This is going to be liters per hour, or per hour squared. Anyways, that's something you don't know how to do yet. C, I'm thinking you could do. It says find r prime of 3. Well, okay, r prime of 3. Well, r prime of 3 is going to be that derivative, the derivative of this right here. So we got to take that derivative. So let's find r prime first. For in general, you can do both pieces, but we really just need that one. Low d high minus high d low all over low squared. Okay, so that's going to be 600t plus 1800 minus 600t over, I'm going to leave the bottom factored. So those guys cancel each other out. And we get 1800 over t plus 3 squared is our r prime t. Okay? And then we're going to plug 3 into that. So we're going to get that. We can divide 6 out of this, and you get 300. 6 out of this, you get 6, and then we get 50. The units, it says, using the correct units, explain the meaning of it, of that value in the context of the problem. So r prime of 3 equals 50. The units are, we just talked about, liters per hour per hour. That's what I meant to write in the last one. So it's per hour squared. It's kind of like acceleration. Okay, so what's the meaning of that? Well, r is already the rate of change of the water leaving the tank. This is the rate of that rate. So the rate at which, so what I'm going to say is the rate is increasing. The rate at which the water, in the context of the problem, the water is draining. You got to talk about the problem. It's draining out of the tank at time. You got to mention the time. This isn't all the time. Time t equals 3 hours using correct units is increasing. So the derivative of the derivative is positive. So the rate is increasing at 50 liters per hour squared. The rate at which the water is draining out, so that rate is changing itself by positive 50 liters per hour squared. It's increasing. The rate's getting, it's, more and more is draining out. Okay, D, I didn't ask you to do, but let's see if we try. It says, write but do not solve an equation involving an integral to find time A when the amount of water in the tank is 9,000. So we need to find a function that describes the amount of water in the tank. So that function is going to involve the integral of the derivative, right? Okay, and I mean that's how we find the function. And so, but here's the deal: we don't actually, we're not going to be able to do it by hand, and so we can just write it in terms of r. This is the same thing as rt, but there's this idea that says if you integrate, it's called the fundamental theorem of calculus, part 2. We haven't talked about it yet. It says if you integrate a derivative, you get the original function. So it's basic idea that integrals undo derivatives, right? So if you integrate a derivative, you get the original function, but then you plug the limits in. That's what you get. Essentially, you get the change in the original function when you integrate derivatives. So here, if we integrate r prime, r, which is the derivative of f, from, well, it's I guess it starts at time 0, right? Starting at time 0, 0, that's where we know something about, to some time t, we get rt minus R0. Now we want RT. So RT, well, no, we'll say F, because R was the derivative. So F, the function, is going to equal the initial amount of water plus all the water that has drained out. Actually, it needs to be, it's going to be minus because it's negative. We're losing it. This should make sense. So our function, and we know the amount at the beginning was 12,000. There's 12,000 liters, and we're going to integrate the rate that we're losing it at from 0 to whatever time you want. Time A, it says. Okay, that gives you the amount at any point. And then they say, well, how can you figure out when it's 9,000? Well, you just set it equal to 9,000. You start at 12, you're losing until you get to 9. You solve this equation, that give you the answer. You guys don't know how to do that yet. This problem was, the point breakdown here was 2, 3, 2, 2. The first problem was 2 points. It was just 2 points, all or nothing. And that's one I think you guys should be able to do now. B was 3 points, 1 point for this stuff, 1 point for the limits and the constant, 1 point for the answer. This one was 2 points. This is something I think you guys could answer. 1 point for finding the derivative at 3, and 1 point for the meaning of it in the context of the problem with all the correct units. And D was 2 points, 1 point for the integral, 1 point for the fact that you even just wrote that, and then 1 point for your final answer. All right, that's it.